Hi, I am Arib. You are watching my YouTube channel. Solar power plant. Definition. In a solar power plant, the radiation coming from the sun's rays are converted into electricity for domestic or industrial use using diverse systems such as solar thermal plants or photovoltaic power plants. Unlimited, clean, and accessible, even in remote areas, solar energy represents an excellent alternative to conventional energy sources, which is key for advancing in the ecological transition. But what types of technologies are currently used to produce it? The conversion of the energy coming from the sun's rays into electricity is carried out in a solar power plant by using different systems depending on its type. The process of electricity production in a solar plant is completely ecological and doesn't generate polluting elements for the environment, as well as being one of the most efficient renewable energies that currently exist. Thanks to these advantages of solar energy compared to energies generated from fossil fuels or non-renewable sources, solar power plants represent a key tool for developing a new long-term sustainable production model, which is completely eco-friendly. Depending on its operating system, there are two main types of solar plants: solar thermal power plants and solar photovoltaic plants. Types of solar power plants and how they work. Although both solar thermal plants and photovoltaic power plants use solar energy to produce electricity, the process to generate it is different in each case. We will explain in detail how these two types of facilities work below. Solar thermal power plant. A solar thermal plant is a facility designed for converting solar energy into electricity through a conventional thermodynamic cycle. However, unlike thermal power plants that work by using fossil fuels, solar thermal power plants use a completely eco-friendly energy source like sunlight. The technology used to produce electricity is slightly different depending on the type of solar thermal plant we are talking about, but its operating system is similar. A solar thermal power plant concentrates the solar radiation to heat a fluid with thermally conductive properties and raise its temperature until it's converted into steam. It's then fed to a turbine. Here, the thermal energy is converted into mechanical energy, which is transmitted to an alternator where its final transformation into electricity takes place. Once the thermodynamic cycle has been completed, the steam is returned to a condenser where it recovers its liquid state and the process is repeated again. From an efficiency point of view, it's important to take into account that the performance of a solar thermal plant depends on the hours of sunshine and weather conditions. Therefore, these power plants also have a storage tank that allows the energy obtained to be stored to use it when necessary. Being a tropical country, receives abundant solar radiation throughout the year. With a high solar irradiation rate, solar power generation potential is substantial. The availability of sunlight it makes an ideal location for harnessing solar energy and promoting solar plant installations. On an average, solar power is received at a rate of 4 to 7 kilowatts per square meter during daytime. Accordingly, the goal has planned major contribution from solar plants out of all the renewable sources of energy in the upcoming plans of the country. It can be observed from Table 1 that the percentage of renewable energy is around 61% and the major component is solar power plants accounting for around 38% with 292 gigawatts capacity alone. Solar plants set up on the roofs of buildings, known as RTS plants, offer several advantages. They utilize available space efficiently, as there is no need for separate land or extensive infrastructure. Rooftop solar installations can be easily integrated into existing buildings, including residential, commercial, and industrial structures. RTS plants contribute to decentralizing power generation and reducing transmission losses. In many cases, RTS plants do not require significant network augmentation or additional infrastructure. They can be connected to the existing power grid, minimizing the need for extensive grid expansion. Overall, solar plants, including RTS plants, play a crucial role in proliferating solar energy. They offer an environmentally friendly and sustainable solution for meeting the country's growing energy demand while minimizing the impact on the environment. Working of solar and RTS plants, a RTS system is designed to convert solar energy from sunlight into electrical energy for use within a building. The solar energy in the form of photons from sunlight is captured by solar PV panels installed on the rooftop of a building. These panels contain semiconductor materials that generate a DC when exposed to sunlight. The DC electricity generated by the solar panels is then fed into an inverter, which converts it into AC electricity. AC is the standard form of electricity used in homes and buildings. If the grid-connected RTS system generates more electricity than is consumed by the building, the surplus power is exported to the utility grid through net metering. Net metering is a metering mechanism which allows for the measurement of both electricity imported from the grid and electricity exported to the grid. The owner of the RTS system receives credits for the excess electricity exported, which can offset the electricity consumed from the grid during times when the solar panels do not generate enough power. Both grid-connected and off-grid RTS systems can incorporate battery storage to store excess electricity generated during sunny periods. This stored energy can be utilized during times when solar generation is low, such as at night or during cloudy days. The focus of the article is on grid-connected RTS systems without battery backup. Illustrates a schematic representation of RTS plant installed on the roof of a building. Overall, RTS systems offer a decentralized and environmentally friendly approach to electricity generation, utilizing available rooftop space and reducing transmission and distribution losses. How do these solar cells work? Thanks to the materials they are made of, when the sun's rays strike them directly, the electrons contained in the more external layers of the photovoltaic cells absorb the radiation and generate direct current electricity. To build a solar photovoltaic plant, these solar cells are connected in series to be integrated into a single module, forming photovoltaic panels. In turn, the solar panels are connected in parallel, forming strings coupled to a current inverter, where the direct current coming from the photovoltaic cells is transformed into alternating energy. Then the electricity is directed to a transformer in which its voltage and intensity are adapted so that it can be transported through the electrical grid lines to the consumption centers. To optimize its operation, the photovoltaic power plant also has a weather tower which analyzes the environmental conditions to identify the solar radiation intensity and its short-term evolution, as well as informing of the exact sunset time. Therefore, it's possible to predict the periods with shortage of light and store the energy needed to guarantee the electrical supply. In addition to conventional solar plants, photovoltaic systems installed on the roofs of buildings known as solar communities, which generate electricity for self-consumption and reduce energy costs, or solar farms, are two great examples of solar photovoltaic power plants.